What?
That was a lot of editing.
Oh no, it's okay. Don't be scared. Don't be alarmed. It's okay.
You sure?
You guys gonna be fine. All right. So what happened today? We're gonna talk about cross-section volume, and the cross-section volume is actually interesting. I don't know why they name it cross-section, but it's very, very, very interesting. Now, this is the shape is unlike that the shape that you've seen before. This is a shape that you never seen before. So what's interesting is this. I am gonna create two different functions. I'm gonna create y equal to square root x and y equal to x squared.
He wants to wait writing this down.
No, you don't wait, just write it down. Okay. So technically the graph is gonna be something like this. This one's for square root x. And this one for x squared. Okay, so now I just want to do 0 to 1. And I'm going to have some cross sections here, this length. Now in this length here, the difference between two graphs, the black line and the red line, we're going to call this D. Or should I call this? Let's call it S. Or should I call it D or S? It's up to you guys. D is for difference or S for side. What do you want?
Let's go with difference.
Difference. Okay, let's go with D. So we can call it D. Like square root x minus x squared is the D. Are we okay here? We're gonna use this D create a shape. Like we're gonna design a shape. The shape that we know. For example, like a square. Right? That's easiest shape that we can find. So we're gonna build this length and build this two-dimensional square and standing up, like standing up on a perpendicular to the graph. I don't know how to graph correctly, but so I'm gonna do a better job here. Is what I'm gonna do is I'm gonna go to decimals. We're gonna go GeoGebra, and hopefully we have Wi-Fi. Oh, wait, we don't have Wi-Fi today? Okay, so this is a two-dimensional shape. This two-dimensional shape, you guys can actually go to it. So you can, if you have a computer, you want to play with it, more welcome. Take out your computer, play with it. It's actually pretty cool. You just look up AP Calculus cross-section GeoGebra, and if you do that, search it up on Google. If we have Wi-Fi, it should come out with this thing here. The person invented this is actually pretty bright. It's much smarter than me can ever dream of. So that square I'm gonna build is that square. Look like this. So if you see on the left hand side is a two-dimension graph, we just convert that to three-dimension graph. And that side of the squares really depends on the D, the difference of the two curves. And are you guys lost? Okay. Do you see that there is on the left side of the graph, you see that purple line, right? You see that distance between those two things, we're going to call it D. Are we okay? We're going to use that D to build a square that's standing up on the graph. Okay? So this is going to look like this one. So this looked like this. It was like this, right? Now it looks like this. I use that D and becomes D squared. D times D is equal to D squared, right? Which is area of a square, right? And not only that, we're gonna go from, you're gonna go here, right? So you see that this D is changing from small to big. Right here is gonna be biggest, right? And then go to smaller. But it's really based on the difference between two curves. Are you lost? No, okay. Now, what happened is I'm gonna go here. So I'm gonna build it with infinite amount of square. So it look like this. What does it look like? Yes, that does look like Sydney Opera.
I was right.
No. It does look like those kind of shape. It turns out Sydney Opera House has a lot of mathematics involved. And I saw this math teacher did a whole video about it. It's actually pretty interesting. But yeah, it does look like something like Sydney Opera House. So the architecture of this is actually really, really beautiful. I have no idea what the actual application besides architecture, but it could be other, and you can make it run like this. It looks like really cool. Can I go upside down? Yeah.
That's crazy. No, it's a fish. Wait, can you make it?
I can make it move. So that each section is a square. Now let's check out if it's an equilateral triangle. Do you see that shape is a triangle now? Right?
Well, but that's just that's from certain angles, right? Or is it from any angle?
It's all triangle. And that triangle, the base of that triangle, this is called equilateral triangle. It's base, like it's just exact, you know, they have the same length, right? They have this length, this length. They're exact same thing. The length is based on the base of the difference between two graphs. Are you guys lost? It makes sense? Okay, now this is the semicircle. It looked like on a raining day, those small, like those, I don't know, or something. I don't know. What does it look like? It look like those things I step on when it's raining day. Slug or not slug, but they have
Looks like a leaf. Yeah, leaf.
leaf. No, leaf is not like this. So in this dimension, you cannot see it.
Yeah.
Look like what?
Like those like dry leaves.
Do you see that? Is that better?
So what's the matter with switching each
Huh?
switching between each shape? Like, is there like
Well, I can design any shape I want to. I can design even a trapezoid, or not trapezoid, but a rectangle or isosceles triangle or even regular pentagon. Yes, I can do that.
Can it be any shape which has size equal?
Any shape that you can find had the size that equal. Yeah, so equilateral triangle, square, you know, regular pentagon, regular hexagon. It can be like that, but I don't know if you want to do it. But you can actually form the equation for that. So I'm going to talk about cross sections. So cross section volume, it has few situations. So first, it has no pi unless you deal with semicircle. So the cross section value, first thing that they will ask you is to pay attention to what they're perpendicular to. There are two types of possibility. Most of the time, it's going to be perpendicular to x-axis. And that just means dx. Sometimes they're going to ask you perpendicular to y-axis. So the difference of that is going to be perpendicular to y-axis. So that's going to be dy. Second thing is I want to find out difference between two graphs. So to find the difference between two graphs, usually difference, I'm going to say difference is equal to top minus bottom, or in terms of dx, right? Or difference could be right minus left. Hopefully that makes sense. Does that make sense or no? top minus bottom, just like what we did before when we did cross section in term of area. And if we do it in term of dy, is right minus left. Are we okay here? Third, usually question we're giving. So question will give the shape. So they will say every base is going to be perpendicular, is going to be a shape. There are a few popular shapes. The first popular shape is called square. The second most popular shape is actually the equilateral. No, it's actually semicircle. On AP exam, on third popular is equilateral triangle. Equilateral triangle. On the fourth popular shape is gonna be isosceles. No, actually, okay, isosceles. Actually, rectangle. And this could be a various of situations.
Rectangles don't have sides of equal length.
The fifth one is there is a 5A is isosceles triangle with leg equal to the base. B is isosceles triangle with the leg equal to the hypotenuse. So those are 5 popular shape. And so let's start with the first popular shape. The first popular shape, make sure no pi. For square, just simply d squared. I'm going to use a capital D. So d squared. It can be dx or dy. Between A to B, A to B. Does that make sense? D times D becomes a square, right? But from A to B is accumulation from one point to the other point is all different kind of shape. In difference is going to be constantly changing, depends on the functions. Are you lost? Does that make sense? Okay, so basically if you go back here, go back to here, this is a square, right? Basically, we found one square is the difference, right? But it's gonna d times d, right? So base times height. So whatever base you got is d, and the height is also d because it's square. So d times d. Now, between A to B, just accumulation of all different square are together. Lost? Understand? Make sense? Remember, they can be perpendicular to y. If they say perpendicular to y-axis, you have to pay attention to perpendicular to y-axis. Everything near converted to dy. Then the is going to be right minus left. So now this is a square. Now what we're going to do is we're going to deal with the next one, equilateral triangle. Equilateral triangle, I'm going to give it to you. It's going to be also d times d, but it's going to be square root 3 over 4. Between, oh, that's semicircle, sorry. I write it wrong. Thank you, good call. So it's between A to B. Now, in this case, D is a semicircle. So if you pay attention to that semicircle shape is going to look like this one. The semicircle is going to look like this. Right? But the D is the diameter. It's not a radius. So you got to pay attention. Do you see that that's the diameter? The difference is the diameter of the semicircle. It's not the radius. So a lot of people get confused. So what happened is that this, you think about is pi r squared, right? So pi r squared. So that lead to integration, well, it's half pi r squared, sorry. Why is half pi r squared? Semicircle, good. So half pi, so again, half pi is in the front, and the d is d over 2. Does that make sense? That becomes a radius. Does that make sense? In terms of d. So let me rewrite it. Half pi d over 2 square. And we're going to just say dx between a to b. Dx. Now, can I simplify this more? Can I simplify that becomes b to a of d squared over 4? Does that make sense? And can I even do it more? So pi over 8 between a to b, d squared over 4. D squared, that's it. So that's the final equation I will memorize. I'll just memorize the coefficient because the d squared is always there. Pi over 8 is different. So we just figure out an equilateral triangle. I'm going to give you the equilateral triangle. The ratio is going to be square root 3 over 4. Integration between a to b, and that's going to be d squared dx again. So the only thing you have to memorize is this part, the purple part, which is if equilateral triangle is this, if this semicircle is this, and they all start with d squared. Now rectangle, sometimes the question they can ask you rectangle. Rectangle, they usually says, okay, well, rectangle base, which is the difference, is 2 times the height. So in that case, is a to b. Well, d is the base. This is the base. But it's 2 times the height. So the height must be half the base. Does that make sense? So it's going to be d over 2 in this particular case. So in this particular case, it was a to b, d squared, and there's 1/2 in the front. It's 2 times. If it's 3 times, then it's going to be 3 underneath. So this is the base, this is the height. Because they say it's 2 times the height. So base is longer than height. So therefore height is half the base. So be careful how the question's worded, and that's something you need to pay attention to. So today you just have to find out the d and decide which shape you're going to use. That's it. You remember it's either d squared, 1 in the front, or pi over 8 in the front, or square root 3 over 4 in front. Depends on the shape again. Isosceles right. This one is actually interesting. If a base is isosceles right, then isosceles right is like this. This is the SS. Well, that's just going to be d squared and a half between a to b dx. It's half. Normally they don't ask that. But if its leg is equal to hypotenuse, then that's different. So what if you have this part here, and you say this is the hypotenuse, right? But you have the hypotenuse. How do you get the other one? So remember the ratio is this is s square root 2 s. So s square root 2 times s. So square root 2 times s is the hypotenuse. Now you want to find out the s. So this is equal to h. So s is much hypotenuse over square root 2. So in this case, it's going to be h over square root 2. That's the psi square and the times half. So they'll end up to be, I think it end up to be 1 over 4 between a to b d squared. So it becomes 1 over 4 because if you find out that psi, the hypotenuse, then you want to find out what's the other side, which is divided by square root 2. And if you multiply 1/2 base times height, so 1/2 base times height, then it's going to be 1/4 d squared.
Why do you multiply it by 1/2?
Because 1/2 base times height.
Oh, so from the regular triangle.
Yeah. And I'm going to answer the last questions here. Why is that square root of 3 over 4? This is actually very interesting. If this, I'm going to write it really small here, but this is 60, 60, 60. And if I break this apart, what does that make this? 30, right? And this 90, right? If this is S, well, S equal to square root 3. So according to the ratio, if you ratio like 30, 60, 90, so this is 60, this is 30, this is 90. If 90 is facing the S, that means this part is S over 2. Now S over 2, that means the height is going to be square root 3 over 2 S. So it'll be square root 3 over 2S times S over 2. So that's equal to square root of 3 over 4 S squared. So that's how you get square root 3 over 4 squared. Has everything to do with that. So yeah, this is today's homework. Just remember, using calculator. Save time, some time. You have answers over there. Make sure you write your